Today we are going to learn how to solve logarithmic equations. We already know how to do ones like number 1, but we're going to do some ones like number 2 in the do now, and ones with logs on both sides of the equation. And I think if you guys are really good with condensing and expanding logarithms, that this should come very easy to you guys. So I want you guys to do 1 and 2, take about 2 to 5 minutes. Pause the video and do 1 and 2. Number 1, if you look at number 1, so it has a log on the left side and a constant on the right side, so it's in the logarithm form that we're used to. So I'm going to take it out of log form and put it into exponential form. My base is the base on the log, 5. My exponent's what the log is equal to, which is 3. My exponent's 3, and it's equal to the argument, which is 2x minus 7. Continue to solve for from there. 5 to the third power is 125, equals 2x minus 7. I'm going to add 7 on both sides there, so I get 132 equals 2x, and divide by 2, and you should get x is equal to 66. But we can't say that's the answer just yet. We have to check our answer for logarithms. That's going to be very important. So let's check it. How am I going to check? So I'm just going to plug our answer in for x. So our answer is 66. So to check it, that would be log base 5. I'm going to plug it into the original equation. You always want to make sure you plug into the original equation, just like any other equation we're solving. You always plug into the original equation. So it'll be 2 times 66, which is our answer, minus 7, and that should equal 3. So you could carry this out one step further. What I would recommend for checking this is I would use your calculator for this. So this would be, let's just plug it straight in the calculator. We should have math. Go to log base. And our log base is 5 of 2 times 66 minus 7. When we press enter, we should get 3. We do. That checks out. And you could do it by hand also, but I think just to save time, it's much more efficient to check it in the calculator. So that checks out. X equals 66 is our answer. Now 2 is one of the new things we're doing for these notes, but I think you guys can actually do this on your own before we go over it. So log 8 plus log x equals 2. How would I make this look like number 1? So we just have one log. We could condense the left side. So log of 8 plus log x, we could write that as 1 log. If we multiply the arguments, so that'll be log of 8x equals 2. Now that we have 1 log on the left side, I'm going to convert this into exponential form. So the base of my logarithm is 10. My exponent is 2. That should equal 8x. We would get 100 equals 8x. Divide by 8 on both sides. You should get x equals to 12.5. Don't circle it as your answer yet. We need to check this, so come over here and check. And we're going to plug in our answer, which is 12.5, in for x in the original equation. So it'll be log of 8 plus log of 12.5 equals 2. You could check this by hand. You could also check this in the calculator. Highly recommend checking your calculator. So that would be log 8 close parentheses plus log of 12.5 Enter. We got 2. Awesome. That checks. So that is our answer. That checks. So that is our answer. So when we have multiple logs on one side, we can always, as long as they're the same base, we can condense them into one log and then solve it as we usually do. Take it out of logarithm form and put it in exponential form. So what should I be able to do by the end of the day? What we're going to be doing is just solving common base logarithmic equations that require me to condense logarithms. So I want you guys, similar to how we did number 2, I want you guys to give 1 and 2 a shot. Take about 3 to 4 minutes and pause the video. Replay it when you're done. So, number 1 on the bottom. If I'm going to solve number 1, I have 2 logs on the left. I'm subtracting them, but they have the same base, so I can rewrite them under 1 log. Since I'm subtracting them, it'd be log base 3 of x over 5 equals 4. We wrote it as 1 log, so now we can take it out of logarithmic form and put it in exponential form. So my base is 3 to the 4th equals x over 5. And we could solve for x from here. So 3 to the 4th is 81 equals x to the 5th. Solve for x here. X is being divided by 5. So what's the opposite of dividing by 5? You'd multiply by 5 on both sides. And you would get x equal to 405. Don't circle it yet. We have to check our answer. So how would we check our answer? You plug our solution in for x into the original equation. So that'd be log base 3 of 405 minus log base 3 of 5. And we should get that to equal 4. Check it in your calculator. That works out. So our solution is x equals 405. And similarly for number 2, the only thing different about here is we have our logarithm now is a natural log, which is a base e, and we're adding. So we want to do the same exact process, make that left side 1 logarithm. Since we're adding 2 logarithms with the same base, that's really multiplying their arguments together. So it'll be ln of 10x equals 7. Let's take this out of logarithm form, put it in exponential form. So our base is e, our exponent is 7, should equal 10x. Solve for x here. I would just divide by 10, and you would get x equal to e to the 7th over 10. But don't circle that answer just yet. We need to make sure we check it. So check to make sure it is a solution. When would it be not a solution? If it made the inside the argument, if it made the argument less than 0, 0 or less than 0. Because remember, in the domain of a natural log, or domain of any log really, there's an asymptote at x equals 0, so it can't be 0 or anything less than 0. So if we have a negative number as an argument or 0 as an argument, it's going to be a rejection. That's not going to be a solution. So when I check it, that would be ln of e to the 7th over 10 plus ln of 10 equals 7. You could check in the calculator. You could also notice e to the 7th divided by 10 is greater than 0, and so is 10. So this also checks. So our answer here is e to the 7th over 10. You can always check that in the calculator. I know I always do, just to make sure. So that's it for this page. Let's go to the next page. So this is when you are going to see when checking your work for logarithmic equations really matters. So, we're going to solve the logarithm at the top, logarithmic equation at the top. We have two logarithms with the same base on the left, a constant on the right. So I'm going to make those logarithms on the left one logarithm. So when I'm adding two logarithms with the same base, I'm really multiplying. I can condense them into one logarithm by multiplying their arguments. So that would be log base 4, and then x times x minus 12 would be x squared minus 12x, and that should equal 3. So now I have it just condensed to one logarithm. I can convert this into exponential form. So my base is 4, my exponent is 3, and it's going to equal my argument, which is x squared minus 12x. You may see it now. Now we have a quadratic equation. I'm going to keep on solving this. So 4 to the third power, let's simplify that to 64, equals x squared minus 12x. It's a quadratic. How do I solve a quadratic function? We want to set the equation equals 0 first, see if it's factorable. If it's not factorable, we can do completing the square quadratic formula. So I'm going to set equals 0, x squared minus 12x minus 64 equals 0. So let's check if it's factorable first. We need two numbers that multiply to negative 64, add to negative 12. Those two numbers, yep, negative 16 and 4. So this would factor into x minus 16. X plus 4 equals 0. We have it factored, so I'm going to solve for it from here. I always do the t-chart. Set each equal to 0, each factor equals 0. We should get an answer of x equals 16 and x equals negative 4. So those are our two potential answers. We need to make sure we check those, make sure they're not extraneous solutions. So when we check them, we're going to plug each solution back in for x. So that would be log base 4 of 16 plus log base 4 of 16 minus 12 equals 3. If you plug that into the calculator, you will see it checks out. Also, you can look at the arguments. They're all greater than 0, so that works. And let's plug in our other possible solution. That would be negative 4. So we log base 4 of negative 4 plus log base 4 of negative 4 minus 12 equals 3. You may see, so you can plug this in the calculator. Actually, we'll plug in a calculator after we see both our arguments. We just need one would be less than or equal to 0, but they both are in this case. So this is not a solution. So our only solution is x equals 16. And I want to show you guys what the calculator is going to show if you do check this one with the calculator. So that would be math log base 4 of negative 4 plus log base 4 of negative 4 minus 12. Press enter. Non-real answer. So that's how you know it is not a solution. It is the only solution is 16. So make sure, I can't stress it enough, when we're solving logarithmic equations, you need to check every single answer to make sure it's a true answer and it's not getting rejected. So I want you guys to take 3 to 5 minutes and do this checkpoint here. Pause the video and play it again once you are done with it. And I'll show you the answer. So, the first step we want to do here is write that left side, those two logarithms, condense them as one logarithm, which is what we did here. And then once we have them as under one logarithm, we can write it as an exponential equation and simplify and solve from there. You see we have a quadratic equation, which eventually leads us to being factored. And then we have two potential answers, but once you check -20, you see that is rejection, but when x equals 5 works. So that would be our solution, x equals 5. Let's go to the next page. Here's the second do now. So what we're going to be doing for the second part of the notes is we're going to be solving logarithmic equations with logarithms on both sides of the equal sign. So I think you guys are going to be able to do this, to be able to figure out how to do this just by doing 1, 2, 3, 4, 5, and 6. So I want you guys to take, this can take probably a little bit longer. Let's take like 4 to 6 minutes and do 1, 2, 3, 4, 5, and 6. Pause the video and play it once you're done. So number 1, x over 4 equals 7 over 4. There's a lot of different ways you can go about doing this one. You could cross multiply. A lot of people do the butterfly method. Honestly, what I do, the denominators match up. They're equal to each other, so the numerators have to be equal to each other also. So x is just going to equal 7. Number 2, remember we can't just add those two fractions on the left. Why can't we do that? Because we need to have a common denominator. So if I'm going to get a common denominator of 9 and 3, that's going to be 9. So I'm going to multiply the numerator and the denominator by 3 here. That's going to give us, I'm going to write this out with every step I can show. So this would be x over 9 plus 3 times x minus 2 over 9 equals 8 over 9. And I'm showing all these steps just so we don't make any mistakes when we're distributing that 3 to the numerator in that second fraction. So next up, I'm going to write everything on the left side as one fraction. So we now have the same denominator, so I can write this under one fraction, under one denominator, I should say, over 9 equals 8 over 9. So now that we have the same denominator, we can just disregard the denominators. We could cross multiply, simplify the numerator on the first fraction, but now since we have 9 and the denominator here and here, we can just cancel them out because we know the numerators have to be the same if they are equal. So I'm going to set the numerator, x plus 3 times x minus 2, equal to the numerator on the right side, which is 8. And I'm going to keep on simplifying it from here. That would be x plus 3x minus 2 equals 8. Combine like terms, not minus 2, that should be a minus 6. So that would be x plus 3x minus 6 equals 8. Combine like terms, that'll be 4x minus 6 equals 8. Add 6 on both sides. And now divide by 4, and you should get x is equal to 3.5. Plug it in to check. Plug in 3.5 in for x in the original equation. It should work. So it checks. Now let's look at when logarithms are on both sides of the equal sign. So it's a very similar format to when we're adding rational equations or equations that involve fractions, numerator, and denominator. So I want you to look at number 3. Number 3 has logarithms on both sides, but look at the logarithms. It's just log and log, which are both log base 10. So if they both have the same log, it's both have the same base, and they're set equal to each other, then their arguments have to be equal. So x has to equal 72. And you should just check, plug 72 in for x, just to make sure it works. Clearly it does, so that would be an answer. Same thing with number 4. Number 4, log base 8, log base 8. They're set equal to each other. So their arguments are going to have to be equal to each other. So x is going to equal 10 here. So these are very similar. 3 and 4 are very similar to number 1. They have the same, they're just 1 log equals 1 log. Number 1 is just 1 fraction equals another fraction, and they have the same basis, or in number 1, the same denominator. Let's look at number 5. Number 5, natural log equals a natural log. So I know their arguments have to be the same. That would be 2x equals 98. X equals, when I divide by 2 on both sides, I get x equal to 49. Before I go circling anything, just make sure you check it. So I'm going to check down here real quick. That'll be the natural log of 2 times 49 equals natural log of 98. That checks. So our answer of 49 works out. And number 6, okay, so it's not just 1 log equals another log, like 5, 4, and 3 were. It's a log plus a log equals another log. How can I write this so it's very similar to the other 3? I could write that left side as 1 logarithm, because if it has the same bases, log, log, both base 10, I can, and they're being added, I could multiply their arguments under 1 logarithm and condense it. So that would be log of 15x equals log of 360. Now logarithms equal each other, and they have the same base. So now I can set their arguments equal to each other. 15x equals 360. Divide by 15 on both sides. You should get x equals to 24. Don't circle at that just yet. We need to make sure we check it. So when we check it, we plug our solution in for any x in the original equation or variable, whatever one we're plugging in for. Log of 360. And when you plug that in, that should work. That is good. And we'll go over this more in the second, in the next page. But when you plug this in, you want to make sure you plug this side in, press enter, and plug this side in, press enter. They should be the same exact number. Let's go to the next page. So I want you guys to take a look at number 1. I want you to give number 1 a shot. Try and do number 1. So I want to do like these question by question by question. So give number 1 a shot. Take, 2 to 4 minutes. Try number 1. Pause the video and play it again once you have went as far as you could. It's very similar to the one we just did. It's just instead of adding 2 logarithms with the same base, we're subtracting 2 logs with the same base. So what do we do when we subtract 2 logs with the same base? In order to condense it into 1 log, we would divide the arguments. So this would be log base 6 of 12 divided by x minus 1 equals log base 6 of 7. So now that we have, let me get this so it's not covering. So now that we have two logarithms of the same base on the left and right side of the equation, that's it. We can drop those logarithms, and we know their arguments have to be equal to each other. So I'm going to set 12 over x minus 1 equal to 7. How would I go about solving this? Oh, helps a lot of people out if we make that 7 right as a fraction, 7 over 1, and then like, oh, I see what I have to do. Now we can cross multiply. So I would do 7 times x minus 1 equals 12 times 1, which is just 12. And we can simplify it from there. So I distribute on the left, I get 7x minus 7 equals 12, which simplifies to 7x equals 19. Divide by 7 on both sides. You should get x equal to 19 over 7. But wait, we can't circle that as our answer yet. We need to check it. So off to the side, just make sure you check. We plug our answer in to the original equation. That would look like log base 6 of 12 minus log base 6 of 19 over 7 minus 1 equals log base 6 of 7. So let's show you guys how to do that in your calculator. So we would have to do the left side first or the right side first, but we want to do them separately. So this would look like math, go to log base of 6 of 12 minus math log base, and I'm going to make it look exactly how we're writing it. I think that really deters from making any mistakes if you write exactly how you're writing it in the calculator as you are on the paper. Minus 1, and then we're going to get our number. That is this number. So now I'm going to also, that should be the same thing as the right side, which is log base 6 of 7. Log base 6 of 7. Do we get the same thing? Yes, we do. So this checks out. And our answer is indeed 19 over 7. So that's what you're going to want to do to check each and every one of these. You have to check both sides of the equation separately in the calculator. So let's look at number 2. Number 2 is 2 ln of x plus ln of 4 equals ln of 9. I want you guys to, again, try this for 2 to 4 minutes. Pause the video and play it again once you're done. So for this one, I'm going to want to once again condense the two logarithms on the left. So we have one logarithm, because then we have one natural log equals another natural log, and we can set their arguments equal. So that first 2 ln of x, that 2, I can write as an exponent, so that'd be ln of x squared plus ln of 4 equals ln of 9. Now we can combine those two logarithms on the left. Since we're adding with logarithms with the same base, I can multiply their arguments equals ln of 9. And now we have two logarithms with the same base equal to each other, so we can set their arguments with the same base equal to each other, so we can set their arguments equal to each other. So that would just simplify to 4x squared equals 9. I have a quadratic equation, so I want to set this equal to 0 by subtracting 9 on both sides. So it'd be 4x squared minus 9 equals 0. This is a difference of two perfect squares, so this would simplify to be factored to be 2x plus 3. 2x minus 3 equals 0. This is fully factored, so we can do our t-chart. We can set each factor equal to 0. And solve for x. We should get x equals to negative 3 over 2 here. And on the right would be x equals 3 over 2. don't circle them as your answer yet. You have to always make sure you check. So when I check over here, plug each solution into the original equation. So this would be 2 ln of -3 over 2 plus ln of 4 equals ln of 9. You should, when you plug this in, this would be a rejection. But when you check the other one, that one should work, but let's just check it to make sure. So that would be 2 ln of +3 over 2 plus ln of 4 equals ln of 9. When you plug that in, that checks out. So our answer is 1.5, or same thing, 3 over 2. Last one on the page, I just want you guys to do number 3. Same thing, take like 2 to 4 minutes. Very similar to the ones we've been doing. Pause the video if you haven't and play once you're done. We want to do the same thing here. We want to condense, in this case, it's the right side of the equation into one logarithm. We're subtracting 2 logarithms with the same base, so we can condense them into one logarithm by dividing their arguments. So this would be log of x minus 5 equals log of 9x plus 4 divided by x plus 4. Now that we have 2 logarithms with the same base equal to each other, we can just set their arguments equal to each other now. So this would be x minus 5 equals 9x plus 4 divided by x plus 4. It might be easier for you to think of this as x minus 5 over 1, because then you can see we can cross multiply. It'll be easier to see that we have to do that next. So now we would cross multiply. So that'd be x minus 5 times x plus 4 equals 9x plus 4. And we would simplify the left side. So that'd be x squared plus 4x minus 5x minus 20 equals 9x plus 4. Add combine like terms on that left side. You can probably do a bunch of steps at once. I'm just going to go step by step here. So that'll be x squared minus x minus 20 equals 9x plus 4. We have a quadratic equation, so we want to set it equals 0. Get everything on that left side. That would be x squared minus 10x minus 24 equals 0. Two numbers that multiply to negative 24, add to negative 10 would be negative 12 and 2. So this would simplify to, in factor, to x minus 12 times x plus 2 equals 0. That's completely factored. So we can do our t-chart from there. X equals 12 is a potential answer, and x equals negative 2 is a potential answer. But make sure you check it, like we always need to make sure we check for any logarithmic equation. So, and you need to plug into the original equation. So this would be log of, I'll check 12 first, 12 minus 5 equals log of 9 times 12 plus 4 minus log of 12 plus 4. You can plug each side into the calculator. Also, we could see all of our arguments are greater than 0. That checks. And let's check negative 2. Got a bad feeling about this one. Log, plug in negative 2 in for x, negative 2 minus 5 right there. We can see, you know what? This argument is already less than or equal to 0. So this is not going to work out, but I'm just going to continue it just for the sake of the problem. equals log 9 times negative 2 plus 4 minus log of negative 2 plus 4. You could check that in a calculator if you want. It's not going to work. It's going to say non-real answer. So our only answer here is x equals 12. So I just want you guys to go on the next page. And the last question before the success criteria and the classwork, I want you guys to take, 5 minutes and solve this equation, very similar to the other ones we've been solving. So pause the video and start the video back up when you're done. So here is the answer. If you look at the first step, everything's the same. We have 3 logarithms all with the same base. We look at the left side, we have to condense those 2 logarithms into 1 logarithm. So what should we do? Since it's adding, we can condense those logarithms by multiplying their arguments together. So that's what we do here first, just like the other ones we've been doing. So after that, we have 2 logarithms that equal to each other with the same base. So we can just set their arguments equal to each other because we know they have to be equal, which we did here. So now we just have it as an equation, a quadratic equation. So whenever we have a quadratic equation, set it equal to 0. And then if you look at this, it's not factorable. So when it's not factorable, we can either do completing the square or the quadratic equation. I chose to do the quadratic equation. So it's negative b plus or minus b squared minus 4ac all over 2a. Make sure you plug in everything correctly. In your answers, you should get our right here. Potential answers, I should say, 3 plus or minus 2 radical 26 after completely simplified. That would give you 2 potential answers, the plus and the minus. You have to make sure you check them. If you look up here, when you plug in that minus, the 3 minus 2 rad 26, you get a rejection. When you plug in the 3 plus 2 rad 26, that is a solution. So our answer is only the 3 plus 2 rad 26. That's it for solving logarithmic equations. We have the success criteria, which would be these 2, explaining why you did each step for solving the equation. I think that's incredibly valuable. That makes sure that you can solve any logarithmic equation I give to you with the common bases. And here's the classwork. Tomorrow we're going to do a lot of practice on this with a lot of different types of arguments we could have.